Hey guys, we're going to use some fundamental trig identities to help us evaluate and do some other things with the different trig identities that we've already learned, okay? So the ways that we're going to use this is we're going to name 4 ways in which fundamental trig identities can be used. So we can evaluate trig functions. When I say trig, that means trigonometric. We can simplify trig functions. We can develop or make new ones. And then we can also solve trig equations. Okay, so we can evaluate, we can simplify, we can develop new ones, and we can solve trig equations. We're going to list the ones that we've already talked about them, but we're putting them in a new light. So we know the 6 trig identities are sine, cosine, tangent, cosecant, secant, and cotangent. But their reciprocal identities look like this. 1 over cosecant. Cosine is 1 over sine. Tangent is 1 over cotangent. Cosecant is 1 over secant. 1 over sine, pardon. Secant is 1 over cosine. And cotangent is 1 over tangent. Those are the reciprocal identities. There are 2 that have also quotient identities, and those are tangent and cotangent. And a quotient means that it's 2 functions being divided. So that's sine over cosine for tangent. And cotangent is the reciprocal of it, which is cosine theta over sine theta. And there are 3 Pythagorean identities. One we talked about in class today, we discovered was sine squared theta plus cosine squared theta equals 1. If I took this main one, which this one is super, super important, so I want you to go ahead and just highlight it. This one's incredibly important. You'll use this a lot in calculus as well. But if I took this entire thing and I divided it by cosine squared, sine squared divided by cosine squared would be tangent squared theta. Cosine squared divided by cosine squared would be 1. And 1 divided by cosine squared would be secant squared theta. So that's another way that we can derive another Pythagorean identity. The last one is if I took the original sine squared cosine squared equals 1 and divided it by sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared. And 1 divided by sine squared is cosecant squared theta. So those are our 3 trig identities. We're not going to work on the 6 even and odds or these cofunctions. Okay? So how would I use the fundamental trig identities to find a value? Okay? And here's how I would do it. First step is you are going to find a way to relate with our identities tangent and secant. We find, if you look up, scroll up here, I see tangent and secant are both related in this Pythagorean identity. So I'm going to write it out under the second Pythagorean identity, which says 1 plus tangent squared equals secant squared theta. Okay. Secondly, we're going to plug in what we're given. So we're given that secant is 2. So if 1 plus tangent squared is secant squared, so secant is 2, then I'm going to say 1 plus tangent squared theta equals 4. Go ahead and solve. Subtract the 1, and I end up with tangent squared theta equals 3. If I take the square root of both sides, I'm going to get tangent theta equals plus or minus the root of 3. So when secant is 2, then tangent is plus or minus root of 3. How could we explain how to use the fundamental trig identities to simplify that secant x minus tangent x sine x? Okay, so we're going to simplify. So to simplify first, we're going to write it in terms of sine and cosine only. Okay, so I'm going to rewrite secant. I know secant is really 1 over cosine. Okay, we're going to do the rest. Minus tangent is really sine over cosine. And then sine, of course, is just sine. So I rewrote it in terms of sine and cosine only. And now I'm going to go through and I'm going to simplify if I can. So I notice here that this is 1 over cosine minus, and then this I can say is sine squared, because sine times sine is sine squared over cosine. Now I notice that we have a common denominator, so I can combine this. 1 minus sine squared x over cosine of x. So right now that's all I can do, except for I'm going to look to use any identities that I have. So an identity that I do have is one of my Pythagorean identities, which is our main one that we learned today, sine squared x plus cosine squared x equals 1. Well, I have 1 minus. So let's see if I can work this in a way that I can use it. I know that if I want to get sine squared to the other side, I can subtract sine squared x to both sides. So this is this based on the same identity, but we're rewriting it so it becomes a new identity. 1 minus sine squared x equals cosine x. So I'm going to rewrite this as the cosine squared x that I just found. So if I've got cosine squared x divided by cosine x, that's going to cancel out this squared and this cosine, and I just get cosine x. Okay? And then lastly, how would we use a graphing utility to verify these? So the way I would use that is on either side of the equal sign would be each their own functions. So we'd say this is y1 and this is y2. So if y1 equals secant x sine cubed x plus sine x times the cosine of x, and y2 is sine x, oh pardon, not sine x, sorry. y2 is right here, tangent x. You're going to plug them in, and if they overlap, then they are equivalent. And if they're equivalent, then the expression is an identity. All right, that's all for our notes today. Thanks.